Okay, so the big picture for this lesson is independent tasks. Now, an independent task is something that doesn't have any prerequisites. So here's the example from the lesson, and you can see the task list, and you can see some dependencies and independent tasks, and also a schedule that results. So let's take a look at what the independent tasks are in this case. Task 4, prepare a bagged lunch. Technically, you can do that whenever in terms of getting ready to leave. Task 6, gather everything to take. Well, technically you can do that whenever also, assuming you're not including gathering lunch in that. Take out the trash, task 7, also independent. Could happen at any time. Tasks 1 and 2 are still dependent on each other. Take a shower and get dressed. Yes, you do need to get dressed after you take a shower, not before. Tasks 3 and 5, preparing breakfast and eating breakfast. You have to eat breakfast after it is prepared, not before. And then that's it. So what you can do is you have the freedom to put independent tasks wherever they fit in as long as there is a processor available. So for example, tasks 1 and 2, those happen first for you. Take a shower, get dressed. Task 3, parent does that one, preparing breakfast. So task 5 should be able to start after task 3 finishes. However, the task for 5 is eating breakfast, and your parent can't eat your breakfast. So that one has to be restricted to you as the processor, but then you can start task 4 next because that's an independent task. So what ends up happening here is your parent ends up doing all the independent tasks, tasks 4, 6, and 7, and then you do tasks 1, 2, and 5. So probably a good way to think about this is do your critical path first, and then you can fill in and sometimes rearrange items that are independent in order to make your schedule overall take less time. There are a couple of algorithms if tasks are completely independent. Completely independent could be something like, let's see, as an example in the lesson about a printer printing print jobs. It doesn't really matter which get printed first, they all get printed. Or let's say you need to send a bunch of text messages to your friends. It doesn't necessarily matter who you send a text to first as long as they all get sent out. And let's assume you're not doing a group text. Let's say you have a bunch of tasks that are independent of each other, and here are the times that they take. 8, 12, 4, 9, just a very simple list. So decreasing time algorithm, what you do there is you rearrange the list into a decreasing time situation, and then you just prioritize the longest task first, and then build your schedule based on that. So you would rearrange to 12, 9, 8, 4, then you assign to processors based on this order of tasks. So you would start with task 12, and then when the processor is available next, you'd put the 9, then the 8, and the 4. And then there's a list processing algorithm, and that's all based on priority list. So let's say this is your priority list, 8, 12, 4, 9. You would assign the processes this way. You would start with 8, then 12, then 4, then 9. So either way, you would get a schedule that is relatively efficient, but it may not necessarily be the most efficient method. You just have to compare and see. And that's the big picture for this lesson.